Let us try to find the horizontal asymptote of this function here. Now, to quickly recap, if you're not sure how to find the horizontal asymptote, let me show you a simple example of a function which has twice of those. So this is the function f, and this function has two asymptotes. One of them is at this point, let's call it a, and another asymptote at this point b. These are values in y, these are heights. And a is an asymptote of f if it bounds the function from above or from below. This is a different formulation. Well, what does it mean for this y to bound f from above or from below? It means that no matter how far you go on the x-axis, let's say this is you, you're doing your quizzes, and you want to go very far on the x-axis, you will always find this ceiling above you. Or similarly, we take you, let's say on walking in the other direction, maybe I'll give you some here. And you're going in the other direction, then you also find a surface below you. You won't be able, as a function, someone walking on this function here, you won't be able to break this barrier. These are like two barriers in which you are locked in, more or less. So this is what an asymptote means. And when I say no matter how far you go on the x-axis in this direction or in that direction, this is the direction of minus infinity, and that is the direction of positive infinity. So, if we want to find the horizontal asymptotes of this function, we better consider the limits as the function goes to x goes to plus or minus infinity. So this is what we want to find. Now, before we proceed, I would like to play a little bit with this expression for y. And so I hope you don't mind if I use the property of the logarithm to bring this power outside. So you get 7 log absolute x plus 7x. Above there's 4x. And then I think you see where this is going. You write here 4 and write here 7. And I factor out both of these 7s. So I get log absolute value of x plus x. And then above there's an x also. And now there are multiple ways to approach this. But I think now we can take the limit. Now I would like to take it. So I'm looking at the limit as x goes to plus and minus infinity of this thing, which is y. Now, 4 over 7 does not depend on x. It's a constant. So no matter what the value of the limit is, it won't really affect it. So we can just place it outside the limit. So this is the limit, x divided by log absolute x plus x. And immediately, well, this might not be immediate for many people, but we will see that the fastest growing term here is x on top, and the fastest growing term on the bottom is also x. So this is actually equal to the limit of x divided by x, which is 1. Now I'm talking about this limit. Right now I'm talking about this, just to be very, very precise. Okay? And now you might be wondering what really happened here. And if you haven't seen that in the tutorial, or if you haven't seen it before, then I will clarify it now. So what we do here is we divide by x. We divide by the fastest growing term. This is a standard process, so you divide x by x, divide log of absolute of x by x, and then you add x by x. This is equal to 1. That is also equal to 1. But this is actually equal to 0 for positive and for negative infinity. And the reason behind this is that the logarithm function grows slower than any polynomial, and this is something we've discussed already, and we already know. So if log of x grows slower, then x will explode. X will become very big compared to log of x. And then if x becomes very big, then it wins the race. And if the denominator gets very big and it blows up, then we get a 0 value. Because remember, if you divide a small number by a very big number, you get a very small number. And if we make this number very, very big, so infinitely big, we will get something that's infinitely small, like 0. So that is just clarification. And well, if that is equal to 4/7, I hope you don't mind if I call this limit L. So I'll call it L, but I won't write it. So L is 4/7 times the limit, which we've just computed to be 1. So the limit is actually equal to 4/7. Now for plus or minus infinity, it doesn't really make a big difference, because if you have I don't want to say positive infinity and minus infinity, but you just divide x by x and you get 1. So no matter what x is, you just get 1. And that's why. And then it's 1 times this constant, and then it is 4/7. So we don't have to worry about the sign that much. Sometimes we have to do them separately, but here luckily we do not.